Hello, welcome to lecture 41 of game theory course. We are in the middle of dealing with the pulling equilibrium. We already have talked about the separating equilibrium when here x is 5 and p equals 0.3. Now, the parameter has changed to x equals 3 and p equals 0.6. And at the end of the last lecture, we talked about that this cannot be the separating equilibrium anymore. So, how do I know this is not separating? I tried. With time consuming, put the numbers and I found a contradiction. So I'll move to the next candidate, the pulling equilibrium. Hope this will work. If not, we have to move to hybrid. The strategy of North Korea when it's sane would be fight. Why? Because we decide to think it as pulling equilibrium. In pulling equilibrium, the different type should act same. And we already know if North Korea is insane, it always fight. Fight is best strategy for him because fight is better than naturally surrendering, and fight is even better than not fighting. Okay? So, North Korea has a death wish. Its ultimate goal is I'll kill some USA soldier and I don't care. Probably I'll die, but that is my happiness, kind of thing. On the other hand, the same North Korea, actually, inside him, he doesn't want to fight. He knows that if he surrender, he would be humiliated, but he can survive. But if he fight, then definitely he would be killed, annihilated by American soldier. So the North Korea saying want to surrender better than the fight, but because we are dealing with pulling equilibrium, the North Korea insane will never choose surrender. So North Korea sane choose fight. So whatever your type is, sane or insane, North Korea will choose fight. Different types, same action, the action is fighting. Now, originally, the North Korea's probability of sane is 40%, 0.4. Why? The probability of North Korea, the belief that North Korea would be crazy is 0.6, which automatically means the belief that North Korea is sane is 0.6. Now, considering that you watched North Korea fought, you do not know their type, but you know North Korea fought in T1. How would you update? You don't need to update. You cannot update because all North Korea act same, regardless of the time. So the original probability that North Korea would be sane, 0.4, would be remain to be same by Bayesian update. Okay? One thing here I want to point out is this common thing. The pulling equilibrium, North Korea will never surrender. The sane North Korea fight, insane North Korea fight. So actually, the number 5, when North Korea surrender, this would never happen. So when North Korea surrender, we think North Korea would be sane. It's kind of automatic, but kind of it's not like Bayesian update. We just assumed this way because the insane North Korea will never surrender usually. So surrendering automatically means sane. However, in pulling equilibrium, in another equilibrium, separating and hybrid, this is true. North Korea sometimes surrender and they are always in that case sane. But in pulling equilibrium, because even the sane North Korea always fight, this has zero probability. So it is something that will never happen, like non-equilibrium path. But still we maintain the kind of assumption belief update as one. This is more complicated than you think, but we will kind of slightly mention that later. Okay, then what would USA will do when North Korea choose to fight in the first period? With 0.6, North Korea is insane. With 0.4, North Korea is sane. So, what would you do? If you fight North Korea, then you will get 0.2. You will get, let's go back. Here, this North Korea may be sane with 0.4, insane 0.6. If US attack, North Korea surrender with 0. If North Korea is sane, it will surrender in T2, and US will get 1 with probably 0.4. But North Korea is insane fight, the USA will get -1. So 0.6 multiply -1, 0.4 multiply 1, the sum is negative 0.2. On the other hand, if US stop attacking, maintaining the status quo, it will get 0. So would US in T2 choose status quo or attack? Attacks, expected payoff would be negative 0.2. Status quo is 0. Status quo would be chosen. Okay, that is why here USA in T2, when it observed North Korea in T1 fight, will choose status quo instead of attack. Okay, knowing that, this assumption we assumed at 6 would be justified. Why? From North Korea's point of view, when it's sane, if it surrenders, it will get -2 and -2. Why? Once it surrenders, USA will think North Korea would be sane and they will attack again and again. So -2 first period, -2 second period. But here, if North Korea fight in T1, US will not think North Korea is insane for sure, but US think it's insane with probability 60%. Therefore, after the calculation, USA will not attack. It will choose status quo in T2. Therefore, in the second period after fighting, the sane North Korea would get 0. So -3 plus 0, -3, against surrender, -2, fight and not fight, choose fight, and let the USA choose status quo is better. That is why the assumption we started now justified, vindicated by the 8. Once I fight, USA will not attack me again. So I will bear with the small sacrifice today so that I will get something big tomorrow. Okay, the final thing left is what USA will do in T1. Is it gonna even start all this thing or will stay out? If USA will stay out, it will get 0 and 0, so it's 0. If USA will attack in T1, with 0.6, it's attacking the crazy North Korea. So they will fight. So -3. -1. I'm sorry. I made a mistake one more time. This is USA. So why this is happening? The USA, the first number, if attack North Korea, actually, we can think this way. Whether it's sane or insane, they will fight. So USA will get -1 for sure. After attacking, it realized, oh, North Korea, it's not good to attack again, 0. So if USA will choose status quo in T1, it'll get 0 and 0. If USA attack, then surely -1 at first and 0. So which is bigger, 0 plus 0 or 0 minus 1? 0 plus 0 is bigger. That is why here USA T1 choose status quo. I'm sorry, about this. 0.6 multiply 1 plus 0, negative 1 plus 0, 0.4 multiply 1 plus 0. So the sum is negative 0.2. Okay, that's my charm, making so many mistakes. Sorry on that. Okay, now move to something more complicated, really. Now, the x remains to be same as 3. P, on the other hand, became 0.3. Okay, in order to be thorough, like let's say, and I'm telling you this is going to be hybrid equilibrium, which means this is not pulling, this is not separating. Why this is not separating? Let's say this is a separating equilibrium. What will happen? Then the sane North Korea always surrender in T1. Insane North Korea fight. So when the US observe that North Korea choose to fight in T1, it would never attack North Korea again. So fighting, no attack anymore. If sane North Korea follow the separating equilibrium, it will surrender and surrender, negative 4, as we saw here. But here, if it choose to fight, negative 3 at first, then 0. So we cannot expect the sane North Korea to choose surrender in T1 if this is a separating equilibrium. So separating equilibrium, adios. It cannot be like you. So no separating equilibrium possible. Okay, what about pulling equilibrium? In order to be pulling equilibrium, North Korea sane, insane always fight. Like here, always fight. Then the probability that North Korea is sane would be 0.7, not 0.4. Okay, so 0.7 you fight. Then what would US do in T2 when it watched North Korea in T1 choose to fight? It fights. Then if it goes again, North Korea is crazy with 0.3 here, and North Korea is saying 0.7. The expected payoff from T2, 0.3 multiply negative 1 plus 0.7 multiply 1, which is 0.4 positive. So would you rather choose status quo and get 0 or attack and 0.4 would you get? 0.4. Then the assumption that North Korea will fight is of pulling equilibrium collapse. Because why North Korea, sane North Korea fight in T1? It expect if I fight, bear with the negative 3 this period, US will not attack me, so I'll get 0. But then it turns out because now the probability of crazy North Korea is 0.3, even though you fight in T1, US will attack again North Korea again in T2. So what is the point of saying North Korea getting negative 3, negative 3? Or negative 3, negative 2 by surrendering in T2? While it can get negative 2, negative 2 by choosing surrender, surrender. So once you know, even though you choose to fight in T1, US will still nonetheless attack you in T2, you have no reason to choose fight and surrender. Because surrender, surrender gives you negative 4, fight and surrender gives you negative 5. So this P0.3 tells us it cannot be a pulling equilibrium. So from x equals 3, it cannot be separating. From the fact the P equals 0.3, it cannot be pulling. What else do we have? The hybrid, mixed strategy. So here, why mixed? The insane North Korea always fight. The sane North Korea, it's always fight, it's pulling, always surrender, it's separating. But the sane North Korea sometimes fight, sometimes surrender. So with probability alpha, it fights. With probability 1 minus alpha, it surrender. Okay? The belief that North Korea is sane when the USA watch North Korea choose to fight would be as follows. What is this? The fact that North Korea fight has two possibilities. Number one, with 0.3, North Korea is insane. Number two, with 0.7, North Korea is sane. And with probably alpha, the sane North Korea may some reason choose to fight. So if North Korea choose to fight, it's either this 0.3, North Korea is crazy, 0.7 alpha, North Korea is sane but fight randomly with probability alpha. And when this happens, what is the probability that North Korea is sane? 0.7 multiplied alpha. So this is conditional probability. Sane North Korea choose to fight. Insane North Korea always choose fight. Then among that, the probability that it's sane. So this is the probability belief updated by Bayesian rule. In this case, that when North Korea choose to fight in T1, it is sane. North Korea fight in T1, choose T1, then what would USA will do? Okay. One thing for sure you should be careful is if US choose to fight all the time, then North Korea, sane North Korea would never fight because surrender is better than fight and surrender. Because the USA will keep attacking whether the North Korean T1 fight or not, then surrender is better. Then we going back to the separating, which is not possible, we already know. What if the US will always choose status quo, never attack? What will happen? The North Korea, the same North Korea will always fight because it will get -3 and 0 instead of -2, -2. Okay, complicated. Take a deep breath and take this record a couple of times, like stopping here and there. I'm sure you understand. This is not a difficult stuff. So, what I'm saying, when North Korea choose to fight in T1, if USA in T2, in this situation, always fight, always status quo, would end up as pulling or separating. But then we already knew pulling and separating contradicts itself. Therefore, the only possible answer is the USA should randomize between status quo and attack. So we are going to assume that the USA will choose status quo with probability beta and attack with probability 1 minus beta. Okay? And after calculation, we are going to get to 9, which I'm going to talk a little bit later. Okay, think first. The North Korea fight, sane North Korea fight, sane North Korea sometimes surrender. That's here. With probability alpha, North Korea sane, North Korea T1 fight, surrender, randomize between them, mixing them. Why mixing them? Because they gives you the same payoff. So if surrender, North Korea, the America will attack again. So -2, -2 for sure. If North Korea fight, -3 at first. But then we know that with probability beta, the USA will choose status quo, 1 minus beta, attack again. Beta, status quo, the North Korea will get 0, attack again. Now it's the second period and you are saying you will surrender. No point of fighting and get -3 because it's the final stage of the game. Pretending does not pay you anything. So it's like -3. You can get lucky by USA choose status quo with probability beta, then you will get 0. But if you're unlucky, 1 minus beta, you will get -2. So this is the expected payoff from fighting. This is expected payoff from surrendering. And these two payoffs should be same. Same here. Otherwise, the North Korea, saying North Korea would not randomize. Therefore, beta, if you calculate this all, beta should be 1/2. Easy, isn't it? So once again, this is a little bit complicated, but then you will understand by thinking, listening, and stop and thinking, beta would be half. Beta is the probability that USA in T2, after watching North Korea fight in T1, will choose status quo. The probability attack, 1 minus beta, is also half. You should remember, the person who is randomizing is saying North Korea. But then, beta, who choose beta? The USA. So in rock, scissors, paper, in order to make Tom indifferent, Bill should choose 1/3, 1/3, 1/3. In order to make Bill indifferent between rock, scissors, paper, Tom should choose 1/3, 1/3, 1/3. Okay, the North Korea in T1 choose to fight. The T2 USA choose to fight after watching North Korea fight in T1. And it's randomizing between status quo and attack. Okay, which means the payoff from status quo, the payoff from attack should be same for USA in T2 under this situation. So first probability is the North Korea would be sane. Of course, if USA choose status quo, that's 0. If USA choose attack, if North Korea is sane, it will surrender and USA will get 1. If North Korea is insane, crazy, the probability is this, and North Korea will fight and USA will get -1. It will win, but with huge casualties kind of thing. Okay, so 0 is the payoff from status quo in T2, and these are the payoff from attack. The North Korea, after they fought in T1, the probability belief that North Korea is sane. This is belief that North Korea is insane, the probability. So sane, surrender 1, insane, fight -1. And this left-hand side should be equal to 0, the payoff from status quo. If you calculate on this, the downside is the same, so 0.7, or this is 0.7 alpha plus minus 0.3 should be 0, which means alpha should be 3/7. What is alpha? The North Korea fight. The same North Korea fight in T1. That is 3.7. So what is the probability that the same North Korea choose to surrender in T1? 4.7. Okay. How was it? It was like easy peasy. Okay. Yeah. So the big thing in finding out hybrid equilibrium is finding out the value of this alpha and beta. Okay. Then once you find that out, it goes as this. Okay? If you go back, the 6 would be North Korea saying fight with 3/4, and the USA will choose status quo with half, 1/2. And this value would be, if you put alpha here, 3/7, it's half. That is why it is half. You put alpha 3/7, it will be 1/2. Okay, what about 9? We are going to do that in the next class, the last, a little bit complicated calculation. This has been the lecture 41, and see you soon in lecture 42.